Okay. So, good afternoon, everybody. So, last time I started to explain how can we program the 8 LEDs we have here on the board. So, I told you we have 8 LEDs here, as you see. So, for any device, so as you know, in this chapter, I'm going to explain how can we program many input-output devices here on the board. For any device, first, I'm going to explain how it is connected. Also, I'm going to explain how can you program it, and then I'm going to explain the code, what code you have to write to program it. So for the 8 LEDs we have, I told you last time, they are connected to port B, as you see here. Okay. I told you last time also all the cathodes are connected together and they are connected to BG1, right? I told you the reason for that is okay. So I told you if you wanna use the LEDs, so this PN1 can be used to enable or disable the LEDs. So all what you have to do very simple, just put zero here. That's it. So if you put zero here, you enable the LEDs. Okay, because zero here, logic zero means 0 volt, right? So if you put here 0 volt, so if in pin here has 5 volt, so the LED should be on, right? However, if you put here logic 1 in or 5 volt, so whatever you put here is not LEDs. So if you put here 0 volt or 5 volt, LEDs are off all the time. Okay. So this one is not, this PG1 is not as enable or disable the 7 segment. And also I told you why they made the design to this way. They designed this way because also the 7 segment are connected to port B. And we should use either LEDs or 7 segment. Okay. Every 7, as you know from here, you see here guys, we have 4 7 segment. Every one of them also has a pin for enable or disable. So one of them has PB0, PB1, PB2, PB3, and I told you the LEDs should have BG1 as I told you, right? So usually what we do, only one of these pins, 5 pins, only one of them is 0. So if I want to use the LEDs, I have to put 0 here in BG1, okay, to enable LEDs. And also I have to put one here, one, okay? Again, one means 5 volt to disable the.
This is really distorted.
Okay, thanks for letting me know this. Let me see. Everything looks okay. Okay, I'm gonna raise my voice. Okay, so again, if there is any problem, let me know, okay?
It's still doing it.
Okay, let me check here. I should have internet connectivity, right? Connected. Can you hear me now or still?
Well, we can hear you. It's just.
Yeah. So let me see here. The voice is distorted.
It sounds like your mic is like inside of your mouth.
Maybe I can put it far. Maybe it's too close.
Yeah, that sounds a little better.
Okay. So the problem may be because I put it too close. Okay, thanks.
Yeah.
I'm sorry, guys, for that. That's okay. Anyway, thanks for letting me know that. Okay. So I was talking about, yes. So here every 7 segment has one pin to enable or disable it. Also the 7 segment here also has one pin. That's why I told you for now, because we are going to use the 7 segment, right? So we are going to put, we have to put here 0, and for PB0 to PB3 you have to put once. Otherwise, if you forget to do that, you will see some random, because if all of them are enabled, you will see some random numbers here. You are not going to damage the board for sure. If you do that, it's not a problem. However, you are not going to see, you are going to see some random number here, right? Okay. Anyway, so later, so for now, what we are going to do now, I'm going to enable BG1 in order to use the LEDs. Also, I'm going to disable the 7 signal because I'm going to use the LEDs. Later, when I explain the 7 segment, okay, so I'm going to do the opposite. So I'm going to disable the 7 segment. Sorry, I'm going to disable the LEDs and then I'm going to enable 7 segment as I'm going to explain later. Okay, so that's what I explained last time. Also, what I explained last time in general, for any port, before you use the port, you have to configure this port input or output, right? You have to do that. And I already I explained last time how can we do that, and this configuration should be only one time. Okay, so now in this program I want to do flashing LED. Okay, so I want to turn the LED that is connected to PB0, right? So I want to turn it on for 1 second, off for 1 second, on for 1 second, off for 1 second, and so on. Okay, so the way we're going to do it is, as you see here, for sure in the beginning I have to do configuration, and then my program, most of the time the program is going to be from 4 to 8. Okay, you will see here. So number 1, we're going to pull PB0 this pin high, then I'm going to wait 1 second, pull it low, then wait 1 second, and then keep repeating this part. Okay, so by this way, if you look at this pin on the scope, you will see a square wave like this one. It is high or 5 volt for 1 second. It is 0 volt for 5 seconds as well. Okay, so here last time also I already explained. Let me maximize this one. Okay, so here I explained how can you do the configuration, and that's what I did here. So if you look at this part here, guys, here in this part, here I configure ports. All the ports I'm using right now output. So here in this one, I configure BG1 output. Okay. Also, I configure here the pin, PB0 output. This is where the LED I wanna turn it on and off is connected. Okay. Also, we are gonna use, as I told you, PP0 to PB3. Okay. So here I also configure them output as I told you. Okay. Also, I told you we need to enable the LEDs. That's what I did here by putting 0 in BG1, right? Also, we need to disable the 7 segment by putting 1 here in from PB0 to PB3, and you can do this way. Okay. So most of the time your program will be here. Okay. Look how it works. Number 1, clear this one first. Okay. So number 1, I'm not going to repeat. I would explain B set many times. I'm going to say B set port B. Okay. I said last time, guys, don't be confused. This port B is going to be replaced by address, right? And it is already defined in the file we include in your program, right? So here you bit set. This is like a memory location. It's address. It's for sure it's not a memory location, but as I said, it's a register, data register for port B. And I told you in programming, all the registers of all the ports, we're gonna treat them like memory location. So any instruction explained before for memory location can be used there. Anyway, so bit set. So this what this instruction is gonna do is gonna pull BB0 high. Very easy, just bit set, right? So now I put 5 volt on the pin. Once you pull this bit high, BB0 here high, so actually you put 5 volt on the pin, and then after that, these 2 instruction is gonna wait 1 second, okay, and then be clear. So here I'm gonna pull the pin low, and then I'm gonna wait 1 second, right, and then go back and repeat. Does that make sense? So from here to here, it takes around 2 seconds, little bit more than 2 seconds, right? Because I'm gonna wait here 1 second, I'm gonna wait 1 second here, and there is a very little time here, very little time here. Is that okay? So now, very easy. You just pull it high, you wait 1 second, pull it low, wait 1 second, and keep repeating. And I told you, if you look at the scope, I have a very nice picture here. You will see something like that if you look at the scope. from here to here, it is 1 second. So it's very easy to generate a square wave. Okay. Now, how you told us these two instructions, we are going to wait 1 second. How can we do that? How can we wait 1 second? Okay. So the way we are going to do it, there is a function subroutine. This subroutine is called delay 1 millisecond. Okay. So this subroutine should wait for y, whatever the value in y, in millisecond. Okay. Now, because I want to wait 1 second, so here before I call this subroutine, okay, so I'm going here in y, I'm going to put 1000 in y because I want to wait 1000 millisecond, which is 1 second. So once I go to the subroutine is gonna wait. You are gonna return after 1 second. That's what I want to say. Okay. I told you this also last time. It's very easy to change the time. For example, if I remove this one and make it 500, so you can make also here 500. You can make the flashing faster. Just okay. Every half second, or also you can just play in this one. You can make it 250. Right? Same thing also with 250. So you can easily change this number to make the flashing faster or slower and so on. Okay. So now I'm going to explain how this subroutine is working. How this subroutine is going to wait 1 millisecond. Y means register Y. Okay. So here I'm going to explain how it works. What is the main idea? I'm going to tell you. Look here, guys. The idea is, I know my clock. I explained to clock before. The clock is 24 megahertz. Okay. So if look at the idea. The idea is I'm going to execute instructions. Okay. This is, as I explained before, every instruction takes some time or consumes some time to execute it. Right. So the idea here is, well, I'm going to execute some instruction. This instruction as a functionality, they are not doing anything, just I want to waste the time, okay? Because I want to stay here for 1 second, for 100 millisecond, whatever. So I want to waste some time. So look what I did. Look at this part first here, guys. Look here. So here, push A. So just look at this part here first. Okay. So push A. This one is going to take 2 cycles. Pull A. 2 cycles. Just I'm not doing anything. You push, pull, push, pull. Look here. Push, pull, push, pull, push, pull. I'm not doing anything, right? Functionality very slow. I'm not doing any programming operation here. I'm wasting time. You got what I'm saying? So this one is going to take 2 cycle, 3 cycle, 2 cycle, and so on. And there is an operation. There is an instruction. It's called NOP, which is no operation. This instruction is going to waste one cycle, right? Also, decrement and differential not equal. This one is going to waste 3 cycles. So total, from here to here, we are going to have 24 cycles. Okay, guys? And, you know, if the clock is 24 megahertz, that means each cycle should equal 1 over 24 megahertz. Is that okay? Or 1 over 24 microsecond. Or for 24 cycles is gonna be 1 microsecond, right? Every cycle 1 over 24 microseconds. That means for 24 cycles is gonna be one microsecond, and that's exactly what's happening here. If microprocessor started from here and go all the way to here, so from to here is gonna take 1 microsecond. Is that okay, guys? For this part, this is instruction 24 cycles, which means 1 microsecond. So it's going to take 1 microsecond to execute the instruction from here to here. Is that okay? Now, if I repeat this part 1,000 times, by this way, I can make 1 millisecond. That's exactly what I did here. Look, let me erase everything. So we agree that from here to here, it is 1 microsecond. But now, I want to repeat this part 1,000 times. So this, I'm using decrement and differential not equal. So this one from here to here, I'm going to repeat this part 1,000 times. Okay. By this way, if you repeat this part 1,000 times, so it's going to take 1 millisecond. That means this part here is going to take 1 millisecond. Okay. That sounds good, right? And now I want to make a delay for y millisecond, for y. Okay, right? So what should I do? Very easy. All what you have to do is you have to repeat this part y times. I have to repeat this part y times to make y millisecond delay. And that's what I did here. Look here, guys. Decrement and branch of not equal for y. So here I'm gonna repeat this part. I'm gonna come here. I'm gonna repeat this part y times. Okay, guys. By this way, I can make y millisecond delay. Okay. Any question about the main idea? The main idea, again, as I said, we execute instructions. You are not doing anything other than just wasting time. Okay. Push ball, so that I can make a certain delay. Okay. So by this way, I have this function, delay YMS, and then this one can give you any delay for y millisecond, right? So you have to put some value in y before you call this function. So if you need 5 millisecond delay, you have to put 5 in y and then call this function. Okay, guys, any questions? Okay. Let me ask you a question now. Look here. This subroutine is easy to use, but it is a little bit inaccurate. This function is a little bit inaccurate. Can anyone guess why it is little bit inaccurate? Inaccurate here means if I need a certain delay, it is gonna be more, little bit. Okay. The reason is, guys, I ignored some instructions. It's gonna take some time, right? So just to make the calculation easy. So for example, here you push X, right? I just ignored it. I didn't calculate this one. Also, you pull X. Also, I ignored. I didn't calculate this one. Return to the subroutine. I didn't calculate it, right? Also, when you call the subroutine, it's gonna take some time to call the subroutine. I ignored it. But usually, these instructions are very limited. Okay, so this subroutine should be, for many applications, should be accurate enough. You got what I'm saying? So, for example, let me clarify what I want to say here. So, if I want to make a delay 1 second, and actually this subroutine is gonna give me 1.0000007. Okay, that's okay. It's not a big deal, right? It's just 7 microsecond more, or just something very little on top. Okay, because just I ignored some instruction to make it easy and so on. Okay, for sure, if you need very accurate, in this case you can use instruction directly without calling a subroutine. If you need it to be very accurate, you can do it. But just to make it easy, I just ignored some very few instructions. They almost take nothing. The error may be less than 1 microsecond, so very little error. Anyway, okay, guys. So, but should be enough. Any questions? Okay. So now I also created another subroutine. We call it delay y microsecond, YUS. Okay, y microsecond. Okay. You can see here, this idea is very close to here, but I just removed the 1000 here because so here I already have 1 microsecond, so I'm going to repeat it, and that's what I did. So here, from here to here, you have 1 microsecond delay, so I'm going to repeat it y times to create y microsecond. Okay. So it's the same idea, but just I removed the 1000 here. Here in every iteration, I'm going to repeat this part 1000. Here, no, I'm not going to do that. So I'm going to repeat this part from here to here. It's going to make 1 microsecond. I'm going to repeat it y times. Okay, guys, any questions? Okay, so now I want to show a video. Okay. So
I'm not sure. Hopefully you can see it. Yes. Here, if you look here,
So let me share. I think I can share the sound. Just give me 1 second. Yeah, share computer sound. Okay.
I put 1000 in Y so that to make the delay.
Yeah, this is 1000, guys. I told you, very easy. I can just modify this number to make the delay bigger or less. And that's actually what we are going to do in the coming lab. By this way, you can generate different square,
Only for
different square signals with different frequency.
1 second. So let's
Here,
look here. Look at the LED. It is on for 1 second and it is off for 1 second. Okay, can we change it? Can we change this time? Yes, for sure. This is very easy, and I can start this one. And now, let's, for example, let's.
I'm gonna play. I'm gonna just change this number. So as you see here, guys,
the time here. That's what I wanna do.
I'm gonna
500.
500.
So the time now is gonna be half a second.
So flashing,
see this one.
we will see now flashing is faster because it's on for half a second, off for half a second.
Okay, look here. It's only half a second.
Okay.
Is that fine? Okay, now let me think. What about?
Look here, I want to tell you something important, guys. Now, so again, I told you, you can just control the time easily, right? Very easy. Just change this number in your program, very easy, right? So my question now, if I make this time very tiny, okay, very little time, what do you think it is going to happen? If I make it 1 microsecond or 1 millisecond, for example, can you see the flashing? Can our eyes see the flashing 1 millisecond on, 1 millisecond off? Okay. That's what I'm going to try now. So I'm going to try to put a very small number and see what's going to happen.
Very short. 1 second, for example. So let me change it to 1 second. Let me see what may happen if we do that. So now Y is 1.
1 millisecond now.
Only 1 second. Sorry, 1 millisecond. Very short time.
Okay, guys. So let's see what's going to happen.
Oh yeah, we have to restart. Yes. Okay.
So can you see here, guys? You can write it at home. You already have the board, you have the program, so you can try it. So you can see that it is, the LED is very stable. It's on and it's very stable because the time is very little. The reason for that is, number one, the device itself cannot turn on and off very fast, right? So it has some speed to turn on off. Even our eyes cannot observe it. So you will see it. It is like on all the time. However, the signal is on off, and so on. Okay, guys, is that clear? Any questions? Okay, great. Now we have in this chapter we have several subroutines in assembly, right? I will explain to two of them. I explained to delay YMS and delay YUS, right? So we have several subroutines in order to make it easy. I'm going to explain more in the future. So we have here keypad, we have put character to LCD and so on. So I'm going to teach in this chapter a number of subroutines. You can just use them in your program to make programming easy, guys. Instead of writing this subroutine, no, what I did, I put all this subroutine in a file, and you can just include them include the file in your program, so that you don't need to write these subroutines, just to make programming easier. You got what I'm saying? So what I did, I stored all the subroutines I'm going to teach in this and in this chapter, I stored it in a file. The name of this file is subroutine.inc. Subroutine, I think it's wrong. U is missing, but you can change the name of it, or you can use the English name this way. Anyway, so this is the file. This file has all the subroutines I'm going to teach. Okay, just to make programming easier, all what you have to do, just include it and then just use all the subroutines. You don't need to write them again. And this is actually one of the main advantages of using subroutines. As I said before, using subroutines, you can just share the code, you can reuse the code, and so on. Okay, so first question, where you can find this file? This file, it is in the course website. I told you on the course website, all the programs I'm going to teach here in this chapter, I put them on the course website, and even I put the name here. So this is the name of this program. I tested them. I'm sure they are working. Okay, so you'll find it with the programs. You will find this file subroutine.inc. Okay, so let me first show you how this file looks like. Yeah, this is the file. You can see here, this is the name of the subroutine, and this is the program. Okay, this is one. Let me go down. Yeah, here also I give you a brief description. This is another subroutine, right? So this is the content of this file. Okay, you can open it, you can look at it. So all the subroutine I'm going to teach in this chapter. Again, to make programming easier, you don't need to type, you don't need to write them. These subroutines, you can just include the file and then just use the subroutines. Okay, so all of them are here. Okay, now the question is how you are going to include the file. So you already have the file, it's on the course website. How you include it? Okay, I'm going to tell you how. On the course website also, I put a very short tutorial on how can you do that. Okay, so let me, no, not this one. Yeah, it's called tutorial on subroutine.inc. Okay, so here I'm explaining how can you include the file. Okay, very easy. So number one, after you open your project, guys, the first thing you have to do, you have to copy the file and put it in your project. If you forget this step, code warrior is gonna give you error. Is gonna tell you where is this file? I'm not finding it. Okay. Anyway, so if you look here, yeah, if you look here, guys, in your project there is a folder. It's called includes. So all files you include in your project, they should be here. Remember, this is the file we include all the time. In the beginning of our code, this is the file we include. You don't need to add this file because this file is already added. It comes with code warrior. You don't need to add it. However, the file subroutine, the subroutine file, this is not coming with code warrior, right? So that's why you have to add it. The way you have to add it, you have to come here to this folder includes in your project, and then you have to make right click, and then you have to select add files. Okay. After that, you have to locate the file in your hard disk, and then you have to add it. So yeah, so here, as you see here, guys, you have to say you have to locate it, and then you have to find it, and then you have to click here to add it. Okay, once you add it, you should see the file here. Okay, guys, so if you don't see the file here, it means you didn't include the file. It means if you use any subroutines, the subroutines I'm explaining in this chapter, if you use them, code warrior is going to give you error. It's going to tell you, I don't know where is this file. Okay, so you have to see it here. This is step number one. So step number one, you have to include the file here. This file is in the course website. This is a very good idea to do that because it's going to save a lot of time, because already you don't need to write the subroutines. Okay, this is step number one. Step number two, you have to include it in your program. But where I have to include it, where? Okay, remember this file MSC9S, this file here, when we include it, we put it in the very beginning, right? Because this file has equate, and I told you before, this is when you have to put equate, right? However, This file, it has code. So it has to be a part of your program, right? So you have to put it here, okay? If this is your program, at the very end, you have to put here at the very end of your program, because this one, this file has instructions, okay, code. So you have to put it in the program area, put it in the very in the last instruction in your, you say include, and then write the name this way, okay? If you do that, you already included the file, and now you can just use the subroutines. You don't need to write them. However, only one small step is remaining. This is also in the subroutines here. I am using a memory variable. It is called byte memory variable counter. Okay, so you have to define counter ds.b1. Okay, because this is needed in the subroutines. You got what I'm saying? If you forget this one, guys, right? So code error is gonna give you error. Is gonna tell you are using counter, but it's not defined. You didn't define it. Okay, guys. So let me summarize what I said. Number one, guys, you have a file. This file is called include. It's called subroutine .inc. You can just include this file at the very end of your program in the code area, and then you have to put it here. Okay, this is gonna make programming much easier, right? Also, don't forget to define a variable counter here, counter ds.b, right? Because this is needed in the subroutines. Okay, guys, is that clear? Any questions? Great. Now I'm going to explain C language. So I'm going to explain how can you do the same program, flashing LED, how can you do it using C language, okay? Before I do that, maybe I want to remind you some operators in C language. By the way, I know maybe some of you forget C language, you didn't, maybe you don't remember it. That's why on the course website, I put here review for C language. So let me open this one here. Review for C language. So here I make a very small like a review on C language. I will try, if I have time, I will try to explain it, okay? Or you can read it. It should be very easy because nothing is new. This is, we already took C language before, but just in case some students may forget it or whatever, or you want to make like a revision. So I already make this one and I put it on the course website as well. And also, as I'm gonna as I'm teaching C programs, also I'm gonna make a very quick revision. Okay, so now there are some operators who are gonna use in C language. So here, this is the bitwise operators, bit by bit, right? So we have this one, ampersand. This one is used if you want to do logic AND, bit by bit logic AND, okay? This one, if you want to do bit by bit OR, sorry, it's not XOR, OR, right? So this is logic AND, logic OR. This one is XOR, again, bit by bit, okay? Next one here, this is complement, not, okay? Once complement, okay? If you want to do this one here, this is right shift. This way, it is left shift, right? So I'm going to show now how can we use them, so don't worry. But these are operators who are going to use here. So the first one here, as I said before, guys, AND is used. Okay, AND is used if you want to clear some bits, right? If you want to clear some bits. What I said before, in assembly, if you want to clear some bits, you can use bit clear, you can use AND, logic AND, right? Here in C, here in C, we're gonna use logic AND. Okay. Same thing for OR. I said in C language, for OR, okay, you can use. Same thing if you wanna set some bits. If you wanna set some bits, you can use OR, okay, logic OR, or you can use a bit. bit set. Okay, here in assembly, here in C language, we are gonna use logic OR. Okay, so let me give you example here. I can say something like that. Look here, guys. Port B. So you can use port B this way. Okay, similar as we used in assembly, you can use it this way in C. I can say port B is equal to port B and okay FE. Okay, so that means you are gonna do this is a byte, this is a byte. You are gonna do bit by bit or bitwise end operation, and the result is gonna be stored in port B. Okay, so I can do this way in C, or you know I can do also this way. This instruction is identical to this instruction, but you know this is just like a compact version of this instruction. So whatever you like, if you want to use this one, they are the same, right? Same thing for OR. You can see your OR. Okay, so what this one means, again, don't be confused, guys. Port B, this is port B, right? So I can use it this way in assembly. Yes, you can. You can use this way. Okay, port B. I can say the new value for port B is equal to port B, the old value, or for 0, right? So what is 0x here? I'm going to tell you what is 0x I'm writing here, okay? So here, yeah, look here, guys. In C language, similar to what we did in assembly, right? If this number is hexadecimal number, you have to put here 0x. So 0x here is similar to $sign in assembly, right? Same thing. If this number is binary number, you can put 0b, right? 0b here is similar to percent in assembly. If you put nothing, this is similar to assembly. If you put nothing, so this is decimal value. Okay, guys. So now you know in C language how can you express the numbers in decimal, hexadecimal, binary. It's same thing like assembly, but you have to use a different prefix here. Okay. The other thing here. So that's what I'm doing here, okay? So very important, guys. We are going to use these two instructions. We're going to use them all the time. Please understand them. If you have any question, unmute and talk to me. These two instructions are very important. We are going to use them all the time. This instruction is used if you want to clear some bits. So if you look at this one here, as I explained before, just give me 1 second. Yeah, so if you look at this one, guys, here, FE. FE is 1, 2, 3, 4, right? This is F. For E, 1, 1, 1, 0, right? So we are doing, this is port B, and you are doing logic AND, right? As I said before, these bits, because you end with ones, so I'm not gonna change these bits, right? And the first bit here, because this one is 0, I'm gonna put 0. So this instruction is used if you want to clear bit 0 of port B. In other words, this one is used if you want to turn the LED off. Because when I clear this bit, I actually turn the LED off. Okay. Same thing here for OR, but OR is used if you want to set some bits, right? And somehow different from AND, because here, the bits you don't want to change, you have to put zeros, right? So here is this one, 0, 0, 0. So I don't want to change these bits, right? Number 4, 0, right? 0, 1, 0. So this is 40, 40. This is this number, right? So that means I don't want to change these bits, right? But I want to put one here in bit number 6, right? And so on. Again, these two instructions are very important, and we are going to use them to set some bits or clear some bits. Okay, guys, any questions? Same thing if you want to do also XOR. Same thing, so you can just put here XOR, okay? This is the example. So this one is XOR. So here, what we do here, we again, as I said before, guys, XOR, it is used if you want to toggle some bits. So this one actually here is 0, 0, 0, 0, 0, 0, 0, 1. So this instruction here, you toggle the first bit or bit 0, right? So you toggle this bit. Okay, toggle means, as I said before, if the bit is if the LED or if the bit is 0, you make it 5. If it's 5, you make it 1. Or if the LED is on, you make it off. If it's off, you make it on. Okay. Again, this instruction and this instruction are exactly the same since from C language. This one just compact, right? Now let's look at the next operator. This one. So this one means what's complement. Okay. So explain to me what this instruction is gonna do. I'm gonna tell you what this one is doing. PTH, this one port H. So here we are gonna read port H, which is a byte. Okay, and then this operator here is gonna complement the byte, and then the result will be stored in port B. Is that okay? Please don't be confused. This one is not gonna change PTH, right? This one is gonna complement the value. So I'm gonna read port H and complement this value, put it in port B. You know, in C language, what comes before the equal sign, this is the one that you change, right? So this one is not you are not gonna change port H, but actually I'm gonna read port H, complement this value once complement, and then put the result in port B. Is that clear, guys? Any question? Great. Now let's explain shift. How can you do shift right and shift left? Very easy. Look here. I'm gonna say port B is equal to port B shifted 3 times. So this one is how many times you want to shift, right? So if you want to shift only 1 time, you can just put 1 here. Okay. So what's gonna happen? This one is gonna read port B, is gonna shift it here 3 times based on the number you put here. If I put 3, so I'm gonna shift it 3 times, and then the result will be stored in port P. Again, you can use this one or this one, they are exactly the same. Okay, guys? This is for shift left. Sorry, this is for right. Now, for shift left, same thing, but the direction should be this way for shift left. Again, here, what this one is going to do, port B is going to be shifted 4 times, and the result will be stored in port B. Question, guys? So let me tell you the conclusion what I said. Number 1, guys, in C language, this is how can you express the numbers in different formats. Okay? Nothing means decimal, 0x means hexadecimal, 0b means binary. This is number 1. Okay? We have operators here. I explain this operator, bitwise operator, like AND, OR, XOR, once to complement, shift right and shift left. So we have these operators, and also as I said in C language, AND is used if you want to clear some bits and you don't want to change the other bits, or is used if you want to set some bits, right? And XOR is used if you want to flip some bits. Is that okay? Or toggle some bits. And I will explain, and we are going to do that all the time, right? So very important. And I already explained how can you do that. And this is also, I already also explained it in C language, sorry, in assembly before, right? Any question, guys? The other thing I want to explain more, guys, and you should be somehow familiar with it, logic, relational and logical operators. This one is completely different. These operators are completely different from these ones. These ones are used for bitwise, bit by bit, right? It's like binary or logic operations. But this one here, this operation are used in when you make condition in comparison, when you compare, when you make condition, right? So when you make condition, this one means equal, right? So this one you check if A is equal to 2. I think explained this one before. Okay. Also here, this one not equal, right? This one greater. So all of these instructions are used to make conditions. And usually, as you know, these conditions are used in if statement, while statement, and so on. Okay. So greater or equal, less or equal. And this one is and this one is or, and this one is not, right? Okay, but how this and is different from the and I explained before, completely different. This again, these are used for conditions, right? So I can put condition one, and condition two, right? So and here is double ampersand. So here, if it is double ampersand, that means this statement is true if the two conditions are true, right? If it is double. But if it is only one, it means this is this is logic and operation, right? And I should not use an instruction this way, right? It's bit by bit and, okay? Same thing for or here, okay? This is for or if you have two conditions and I want to execute the body of if if one of the condition is true, at least one, okay? So let me give you some example, very quick revision for C language. So if we say something like that, guys, if E1 is equal to E2, and then I put the statement here, this is the body of if, okay? So let me make it this one, okay? So here, I'm gonna execute the body of if E1 is equal to E2, right? That's very easy, right? As you know, if the body of if is only one statement, so you don't need to use braces. If you want to use braces, that's okay. It's not wrong, right? However, if the body of if is more than one statement, you have to use braces, right? So you can use braces all the time. It's not going to make a difference. However, if only one statement is the body of if, maybe it's easy just to put it without braces. Anyway, so here, okay, what this one means, this instruction means, if E1 does not equal E2, right? So I'm going to execute the body of if E1 does not equal E2, right? This one here, we're going to execute the body of if E1 is greater than E2, right? Less than E2, less than or equal, right? Any question, guys? It's very easy, right? Any questions? Okay. If you look here at that's what I told you before, guys. Look here. Now, this is a condition. This is a complex condition. Look how it is. If I is greater than 0 and I is less than 10, right? So that means I'm going to execute the body if the two conditions are true. Both of them should be true. I should be greater than 0 and it has to be less than 10, right? Both of them should be true. Here I put two conditions, right? And then here I put in the middle here, I put or, relation is or, okay? And when it is or, that means I want to execute the body of if at least one condition is true, because this is or, right? At least one. If the two condition is true, yeah, that's more than what I need. All what I need, if at least one condition is true, please execute the body of if, right? So anyway, so you can do this way or that way. This is for and, this is for or, okay? This is for not, okay? You know, not is gonna flip. So that means if this one is true, so not is gonna make it false, right? So that means I want to execute the body of if this condition is false, right? Not true, false, because I put here not. Maybe it's very rare to use it this way, because I can simply say if I does not equal 2, right? But it's also something you can learn. So here again, this one means if this condition, okay, is true, this operator is gonna flip, it's gonna make it false. And now because it is false, we're not gonna execute the body of if. However, if this condition is true, is false, this operator is gonna make it true, and then you can execute the body of if, okay? So I think that this is very important and something very weird actually in C language, very weird. I'm gonna tell you now. Look here, guys. I told you before, if you wanna check some bits, I already explained right now. If you wanna clear some bits, you have to use and. If you wanna set some bits, you have to use all. If you wanna flip some bits, you have to use XOR. Also, I explained in assembly, and also this is the same thing we're gonna use here, is what you have to use and if you wanna check some bits, okay? That's what I said before, remember. So this is a pipe, I wanna check this bit. I want to check if this bit is 1 or 0, okay? And I don't care about the other bits. So the bits you don't want to change, the bits you don't want to check, you have to put zeros here, okay? So I'm going to put another 1 0, okay? Okay. So here, and then I'm gonna put 1 under the bit I want to check. Okay, that's what I explained before. Nothing is new, right? So here I'm gonna get here bit 0 and then bit 0, and then I'm gonna get here 0, 0, 0, 0, everything is 0. Then I'm gonna check the value. This value is if this value is 0, that means bit 0 is 0, otherwise bit 0 is 1. Make sense? That's what I explained before, and that's what we are gonna do in here in C language. Right? So how can you do it in C language? Okay, look how I'm gonna do it. So I can say if PTH, again, PTH is port H, and as I said before, the switches. Let me go back. The switches. These switches are connected to port H, right? So this is input. So these switches are connected to port H. So if I want to know, for sure I'm going to give you details later. So if this is port H, okay, guys. So if I want to know every switch here, every switch should have 1 bit here, 1 bit, right? If this bit is 0, that means the switch is connected. If this bit is 1, that means the switch is open, right? So if you want to know, if a switch is connected or not, all what you have to do is you have to read port H, which is a byte, and then you have to check the bits, okay? Corresponding to the switch you want to check, okay? So, okay, now how can we do it? Okay, I can do something like that, and that's wrong. So let me explain it first, because this is somehow weird, okay? So, so this is how can you do it? Okay, so I can say if BTH and 02, so 02 here, guys, is 0, 0, 0, 0, 0, 0, 1, 0. So you want to check this bit, okay? Or this is switch. In case of PTH, this is switch, right? So I want to check if this bit is 1 or 0, okay? So if the result is equal to 2, that means this bit is 1, right? This bit is 1. That means the switch is open, okay? So how we can do that? This is how can we do it, guys. You can say if PTH and 02 is equal to 2, right? So now I want to do something, that means the switch is open, right? If you put 0, that means the switch is connected, right? Because after you do this AND operation, you should get one of 2 values. You can get all zeros, right? And that means this bit is 0, okay? So if the result is 0, that means the switch is connected. Or you can get 0, 1, and everything is 0, which is number 2, okay? And this means the switch is open anyway. So here I want to search for open, or I want to check for open. So I can do something like that. But you told us this is wrong. Why this is wrong? It's somehow weird. I'm going to tell you why, just to understand it, okay? So everything looks okay, right? So here, this is PTH and this number. So it has to calculate this value first. And then after I calculate this value, so it's going to check. It's going to check if this value is equal to 2. So why you are telling us it is wrong? Yes, it is wrong because this is how C language, in C language, when you have operations, there is priority, right? So some operation should be done before others, okay? For some reason, they give more priority to equal than this one. You got what I'm saying? So what C language is gonna do different from what you want to do. What I want to do is I want to do this one first. I want to do this operation first, right? And then I want to check the result with this one, so this operation second. That's what I want to do, right? However, this C language doesn't work this way, because equal, this one, has more priority than this one. So it's somehow funny. So what C language is gonna do is gonna do this one first, check if this one equal, and yes, 2 is equal to 2. So it's gonna replace it. I told you before, when there is a condition, if it is true, it's gonna replace it by number 1, right? And then if it's false, replace it by 0. Okay, that's how C language works. Anyway, so this one is gonna be replaced by 1, and then you are gonna do AND operation, and then look at the result. If the result is 0, means the condition is false. If the result is 1, means the condition is true. For sure, that's not what you want to do. So it's very simple. How I can fix this problem? Okay. The way you have to fix this problem, you have to use parenthesis this way here, guys. Okay, as I did here. So that you need to do this operation first, and then after that you check. Okay, guys. Any questions? Very important. So this is what I'm going to use later when, if in C language, if you want to check if some switches or a switch is connected or disconnected, right? Easy, guys. So we have port PTH. Every bit here is associated with a switch, right? So if the switch is open, so here it is 1. If the switch is connected, here it is 0. So all what you have to do is you have a byte, you just check the bits. Okay, so you need to check 1 bit or whatever you want to check, 1 or more. So you want to check the bits to see if they are 0 or 1 to learn or to know if the switch is connected or not. And after that you can see what you want to do. If the switch is open, what do you want to do? If it is closed, what you want to do? Okay, guys. So we're gonna do this one later when I explain to port H. Okay. Any question? Please don't forget this parenthesis here. Parenthesis. Don't forget them here. Otherwise, it's not gonna work. Okay, guys. Any question? Great. So now I'm gonna teach how can do flashing exactly same program in C language. Okay. So in C language, number 1, you have to put here some include instruction. Some of them already like this is the file will include in assembly. So you can include the same file here, right? Also, you need to define what microcontroller you are going to use. So you have to write this instruction this way just to tell the code where because it can be used for different processors. So I have to different microcontrollers. So I have to tell which this is, I told you before, this is the number of our microcontroller, this one. Okay, anyway, so this is the program is here in C language. As you know, guys, in C language we have a function, we call it the main function, right? This is the main. So when you execute your program, you actually execute the main function, okay? And this function can call other functions, right? But other function cannot call the main, as you know. Okay, anyway. So always in C, this is the name of the program. You can find it in the course website. So for this program here, always in C language, we are gonna call this function BLL initialization. So this one, we always were gonna do that. This one actually is gonna do initialization, okay, to the system. So we just call it all the time. So it's gonna do, it has some instruction to do initialization so that you can set the clock frequency to 24 megahertz. Okay, that's number 1. Number 2, as I said before, in assembly, same thing. Believe me, everything I did in assembly, I'm gonna do it here, but using the instruction of C language. Okay, so now I'm gonna use port B, right? So you have to configure data direction register B, similar to what we did before. So I can write this one this way, right? So here this instruction here, this instruction here, you configure the whole port as output, okay? Or you can if this one is DDRB, you don't need to define DDRB because once you define the micro, I'm saying that because you know in C language, any variable you want to use, right? You have to define it, but this is not a variable. This is a different story because this is already defined here. Okay, when you tell what microcontroller, you can just use them, the name of the registers. Okay, so the name of the ports and the registers of the ports, but we're not going to use register X or A as you will see. Okay, so for example, here I configured the whole port output. You can use you can only configure one pin, right? So here it should be output. That means you need to put 1 here, right? So you can use OR operation to put 1 here and don't change anything. Yes, you can do this way as well, right? So here, same thing for data direction register. So here I put FF. So here I configure everything as output, right? Maybe you don't, maybe it's here. It's not a big deal. It's not make a difference here because yes, I want to only care about VG1, right? But I'm not going to use the other. I'm not going to use the other ones, right? So if you configure the other ones as input or output, it's not going to make a difference. However, maybe in other programs, it's going to make a problem. Here, I configured everything output. Everything is output, okay? But actually, what I'm going to use is only VG1, right? Maybe this is just easy to do it. It's okay here, right? But it may make problems later if your port, some bits are input, some bits are output, right? So it's not, it's easy. So the way you can do it, you can use, if it is output, right? So you can use OR operation, as I explained before here, right? So you can use something OR, like this one here. Okay, so here, same thing for port P. So this three instruction, I configure ports as, I'm going to use 3 ports as output, right? So this is, again, nothing is new. This is similar to what I did in assembly. I'm doing it here. This is configuration, initialization, whatever you want to call it, okay? Now, BJ, I put 0 in all the ports, okay? PTG, again, it's not going to make I have to only, or I care about BG1, right? But here I put to everything. Okay, it's not a big deal here because I'm not going to use the other ones, right? Same thing here for PTB. PTB, I put ones everywhere. So all of them are ones, right? So just let me clarify what I want to say, guys, because this one is going to make a problem later. If your program has C7 segment and also what we call RGB LED, because PP0 to PP3 are used by 7 segment, right? But PP4 to PP7 are used by RGB, right? LED. So if you change everything, maybe you are gonna make a mess in the RGB LED, okay? But again, here in this program, it's okay because in this program we don't use the RGB. Okay, so tell us, maybe this easy to run this way, but it may not be very accurate. Maybe I don't. Maybe it's just to be in the. That's okay, but just to keep in mind, right? If you are not going to use the other bits, it's okay. But if you use it, what should you do? I'm going to tell you what should you do. So, for example, here I want to set 4 bits. I don't want to change the other bits. So the way I can do it, guys, look here. I can say BTB is equal to BTB. And now because you want to set some bits, you have to use or 0x, okay, and 0f. That's it, right? So if you do something like that, so I'm going to set the first bits, 4 bits, PB0 to PB3, but I'm not going to change the other bits, PB4 to PB7, because they are connected to RGB, and I don't want to change the RGB now. I'm going to explain later what is RGB and LED. Okay, guys? So, again, the difference between this one and this one is going to write to the whole port. This one will be more accurate because I want to write 1 only to BB0 to BB3, right? So, you can do it this way as well. Okay, anyway. Now, so this is similar to what I did before in assembly for initialization. Most of the time the program will be here, most of the time. So we're gonna do while one. I told you while one, as I explained before, this is how can we create infinite loop. So because one means it's like you have a condition that's almost true, right? So because if you put a condition here, the signal match should evaluate this condition. If it is true, it's going to put 1. If it is false, it's going to put 0, right? So you have a condition if it's always true. That's why this one is going to be forever. Okay, now, look here what I'm going to do. Here in C language, guys, also we have a number of functions. I can just use these functions. So we have a function here. This function is called LED on. Okay, this one, this function turns one LED on, but you have to give me the number. Which one? So here I have to give a number from 0 to 7, right? So here, so LED on, if I put here 0, so this one is going to turn the LED number 0 on, this function, right? I describe it here, LED on, so this one is going to set bit number B, whatever you put here, so that means it's going to turn one LED on. So here, this one is a function that you can use to turn one LED on, right? And then MS delay, right? This one is similar to delay YMS I explained before. Let me go back. Yeah, this one I explained before. So delay YMS is used in assembly, but MS delay is used in C, so it's exactly the same thing. So MS means millisecond delay. So here I can put 1000. So here by this way I can make a delay for 1000 millisecond, which is 1 second, right? And then we have another function called LED off, right? So this one is used if you want to turn an LED off. Just give me the number here, okay? So again, this one is gonna turn LED number 0 on. This function is gonna wait. It's gonna make a delay for 1000 millisecond, which is 1 second. This one here, okay. This one here. Yeah, you are gonna turn LED 0 off, right? And then you are gonna wait 1 second. Keep repeating here. Okay, guys. Any question? Great. Okay. One more thing I want to tell you guys here is the following. I did, that's what I explained right now. DDRB equal whatever, DDRG equal whatever. That's what I explained, right? However, if you want to use it this way, it's totally fine. It's correct. Okay. However, we can use functions. We have two functions that can do exactly the same thing like this one, right? So you can say segment 7 disabled. So we have another function, guys. It's called segment 7 disabled. So this one is going to disable 7 segment, right? We have another one, LED enable. So these two functions are going to do the configuration. They are going to define port output. This port is output. It's going to put this value here and this value here. Okay. So again, if you want to use this one, it's okay. If you want to write this way, it is okay. Okay, guys. However, I want you to understand this point because it's important. Okay. This is style. So it's like a simple style. As it's like both of them are okay. I'm not saying anything. Both of them are okay. But this style is like a simple style. This is like C style. Why? Because what is the difference between C and assembly? The main difference is assembly, you should know the details, right? You should know we have a port B, we have port J, we have port P. You should know you have to configure. That's what I mean by details, right? C language is high level language, okay? So all these details are hidden. All these details are hidden inside these functions, right? So it's very high level. Okay, so that means you can program the microcontroller without even knowing the names of the ports you have. You got what I'm saying? Just very easy. If you want to use the LEDs, just use this function to enable, this one to disable. And anyway, so what I'm saying, guys, when you program C language, sometimes we use functions to hide the details so that you can program the microcontroller even if you don't know the hardware or the details. Okay, so again, if you want to program it this way or that way, or using the two functions, they are exactly the same. Any question, guys? One more thing, I told you guys, if you look at this one, LED on. I told you this one should turn LED number 1 on. Number 1, by the way, is second one because we start from 0 to 7. So number 1 is the second one. Okay, anyway. So word LED number 1 on. This one, okay, you can write it this way if you want, or you can write it this way, right? It's exactly the same thing. Port B equal port B or 0x02, right? Because this one is this instruction is used to set bit number 1. So this one to set bit, right? So if this is again, this is assembly style, but again, this is okay, and this is also okay. So here's something here. If you want to turn it off, so you can use it here. You have to use AND because you need to clear bit number 1. Okay, guys. So you can use this one, or you can use this one, or you can use this one, or use this one, whatever you like. But again, you should understand from this slide, you should understand what is the difference between assembly and C, right? Assembly, in order to program using assembly, you have to know the hardware, you have to know the details, you have to know that LEDs are connected to port B. That is why you have to configure port B output. You have to know that you have the LEDs are connected to BG, the cathode is connected to BG. That's why you have to put 0 here. You have to know all of that, right? However, in C, it's high level. Okay, all I can tell you, just use this function, and the details are hidden, right? Again, just you should understand the difference. But in this course, in project, in anything, as I told you many times, if you use this one is okay. If you use this one, I'm okay. As long as the program is working, I'm fine. You got what I'm saying? So if you use this way, okay. This way is okay. Any question, guys? Okay. This is another program. By the way, in this slides or in this chapter, I'm not gonna follow the order, the same order here. Because I need to cover the topics that we need for the labs first. Okay, so but I'm gonna explain everything as you know. Okay, so now so in the coming lab, by the way, before I forget, in the coming lab is very easy lab, very interesting. I just because the coming lab is the first lab, we are gonna use the board. I made it very easy lab because some students will have problem to connect the board, so I didn't make it difficult, so it's easy lab. So in this lab, I'm gonna ask you to use this program, the program I taught right now, okay? And then I'm gonna ask you to generate different screw wave, okay? So for example, you can generate screw wave this way, you can generate screw wave this way, right? It's very easy. It's a simple program. You can just change the blade, right? Change the blade here. Okay? Also, the second part so what I want to say in the first part of the lab is just a little modification to these two programs here that generate square wave, right? C and assembly. The second part is related to the program I'm going to teach now. Also, little modification to this program. Okay, so let's explain what is this program. This program we call it serial data. Okay, so here in this program, I want to use a microcontroller to send serial data. So what you mean by serial data first, before you explain the program, I'm going to tell you. So for example, if this is a microcontroller and I have a pin here. Here I'm using PT0. PT0 means port T, pin number 0. PT0. Okay, guys. So if you look at this picture here, I want to send the data serial. So what do you mean by the data serial? It means if you look here, this is the time, and this is the value of PT0. If you look at this pin, you find this pin is 0 volt for some time, and then 1 volt for some time, 0 volt, 0, 5, 5, 5, and this is the information, right? So here, every certain time, you output 1 bit. That's why it is serial. Serial because you're using only one pin, guys. So that's what we want to do. What I want to do in this interesting program is I want to output this code, okay, or this information. I want to send it serial on the pin. I want to send it serial. So if I look at this pin, I have to see something like that. Okay. However, if you output it at one time, if you output this information only one time, it's going to be too quick for you to see. Okay, because you know the scope is going to disappear quickly. That is why I ask you to repeat. Okay. Again, in reality, in communication or in reality, you don't need to repeat, right? Unless there is a reason for that. But here, I want you to repeat so that you can see to the scope. That means you have to output 0 and then output 1, 0, 0, 1, 1, 1, 1, and then repeat again. Again, the reason for this repeat is just to be able to see it. So if you look at the scope, you will see something like that on the scope. Okay. If you don't repeat, it's going to be one time quickly and you're not going to see anything, right? So that's what you're going to see in the scope. So this is the information 0, 1, 0, 0, and then 1, 1, 1, I guess, for once. Okay. And then 0, and then 1, and then 0, 0. You repeat, right? So you repeat. One from here. Right? So anyway, so this is, you can see here the information, you keep repeating this information on the pen. This is how it looks like on the pen. Very easy, very interesting program. Mostly several communication, right? So let's see, I'm going to explain now how can we do that, okay? The way you are going to do it, okay? Look here, guys. I have a memory. This information is stored in memory 0, 1, 0, 0, 1, 1. Okay, so now the way I'm gonna do it, as you will see right now, number one, I'm gonna shift left, right? Shift left, left, 0, 0, 1, 1, 1, 1, 0, right? And this bit should go to the carry. Is that okay? Why you shift it left? I shift it left because I wanna get this bit, I wanna get this bit in the carry. Why? Because after that, I'm gonna check the carry. If the carry is 0, I'm gonna output 0. Bit clear, right? If the carry is 1, I'm gonna output 1. Bit set. Very easy, right? So all what I'm gonna do is, okay, in every iteration, I'm gonna shift so that one bit is gonna go to the carry, and then I'm gonna check the carry. If the carry is 1, output 1. How do you output 1? Bit set, right? If the carry is 0, output 0. Bit clear, guys. But there's a small problem here. What is the small problem? After each iteration, okay, I'm gonna get 0, 0, 0, 0. So I don't want that. I want to repeat, right? That's why what I'm gonna do is, look here, guys. What I'm gonna do, if the bit you output here, I'm gonna put it here back again, right? So that after each iteration, I'm going to get the same number again. So what I'm doing is something like you rotate using shift, right? I think it's the last level is something like that, okay? So this bit is going to go to the carry, okay? And then based on the value of the carry, I'm going to go back, put it here, 0 or 1. I'm going to put it here, right? Also, I'm going to put this value on bit here. When I put it back here, so that after iteration, I'm going to get the same number again. Let me show the program quickly, you will understand it. It's very easy. So here, this is the number I want to output. I put it in equate, okay? And this is a memory location I told you about, right? And then I'm gonna write this number in this memory location, okay? And then also here, because I'm using BT0, so you have to configure BT0 as output, right? I told you that. This is initialization. So this part here, it is here. So here I configure BT0 output. Right? So most of the time the program is going to be here. So all the time you are going to be here. This part is just a configuration, right? So what should I do here? I'm going to tell you this is exactly what I explained. Look here, guys. Number one, shift left to P. So your information is here. Number one, I shift left. So this bit is going to go to the carry. Okay, great. And then I'm going to check the carry. If the carry is high, look here, guys. Range if carry is set. If the carry is set, go to high here. If the carry is 1. What should I do if the carry is 1? I have to do two things. Number one, BT0. It should have 1. Number 2, I have to put 1 back here. Okay? So that after each iteration, I get that's exactly what I did. If you look here, guys, what I did here, I'm going to say bit set the BTT for BTT, right? 0, 1. Right? So here you set BT0. Okay, so here BT0 you set it. Okay, because this bit is 1, I'm gonna put 1 on in BT0. Also, bit set for the first bit here. I'm gonna put here. I'm gonna set this bit here. Okay. Now, what if the carry is 0? This branch is not gonna be taken. I'm gonna come this way, right? So if the bit here is 0, what should I do? I'm gonna come this way, right? So when I come this way, it's exactly the same thing, but I'm gonna put 0 instead of 1 on BT0. Also, I'm gonna put 0 here. Okay, that's what I did. Look here, guys. Bit right? So here what I did, I'm gonna make bit clear for BT5 because this bit is 0, so I have to output 0, right? And then bit clear to this bit. Actually, you don't need this one. You know why? You don't need this one because when you shift, you shift to 0. So already there is 0. No need to go and write 0 again. It's only 0. You got what I'm saying? So you don't need it. Okay, guys? So this is how it works. Any question? Just in one, I'm gonna say it quickly again. The idea is, guys, here we have a number here in P, right? So I'm gonna shift left so that this bit should go to carry. Now I'm gonna check the carry. If the carry is 1, so I have to write 1 on BT0, right? If the carry is 0, I'm gonna output here 0. Also, this value needs to write it here back so that after for repeat. So after I'm gonna get the same number again to repeat it again. So I start from here and I move back to here, right? You can put some delay here. For sure, there should be some delay. This is the delay here. So if I need 10 milliseconds, so that means here this part is 10 milliseconds as you see here. I think it's the delay, right? When you output 0 or 1, you have to keep it for some time, right? That's why there is some delay here. You can get it here you can use delay values. Okay, guys, any question? So tomorrow we're gonna have a test and then we're running the lecture also. Okay, guys, bye.